Okay, in the diagram of circle L, segment TK is tangent to circle L at point T and segment LK is drawn. If the measure of angle K is equal to 12x plus 2 degrees and the measure of angle L is equal to 32x degrees, what steps should Emma take to correctly solve for x? B. What is the value of x? Select one answer choice for question A and select one answer choice for question B. Okay, I will just share a pet peeve. I dislike the word should because it's very rigid and very judgmental based. Like, you should do this. That's the only way it is able to be solved, which is not true. Math has very many ways that it could be solved. So, I'm going to replace should with could because it's an option. If you found a different way, awesome. If it's not listed in here, sorry. It wasn't one of the ways that it was thinking of. So on this, I would just go through. She should add the angle measures together, set them equal to 90 degrees, and then solve for x because the measure of angle KTL must be 90 degrees due to the fact that TK is tangent to circle L at T. She should set the measures of angles K and L equal to each other and solve for x because the acute angles must be congruent in a right triangle. So is this one true or is this one true? Well, I can think of one that would disprove this one. It's a very common triangle. It's called the 30-60-90 triangle, because the acute angles are 30 degrees, 60 degrees, and then we have the right triangle, 90-degree angle right there. So no, they do not have to be congruent in a right triangle. So that one's right off the list right there, because I could think of one that didn't fit this or proved it wrong. So A, she should add the angle measures together, set them equal. So this is laying out our exact what to do. So we are going to add the angle measures together. So the angle measures are angle K plus angle L and set them equal to 90 degrees. Okay, then solve for x. So now I'm going to say solve for x. Alright, well, angle K was 12x plus 2. So I'm going to replace angle K right there with 12x plus 2. And angle L is 32x. So I'm going to replace angle L with 32x. So we have that 12x plus 2 plus 32x equals 90 degrees, and we want to solve for x. Well, first we're going to combine like terms, and they're the ones that have the same variables with the same exponents. So this 12x and 32x are like terms because they both have the variable x attached. So 32 plus 12 is 44x plus 2. That 2 still didn't go anywhere. Plus 2 is going to be equal to 90 degrees. That equal sign. And that 90 degrees didn't go anywhere either. Now we're going to solve for x since we have everything, all of our like terms gathered together. Our goal is to reach some form of x equals blank. So notice in our goal, it doesn't have any other numbers next to it. So we're going to subtract the 2. Subtract the 2 from both sides. So 44x minus nothing is still 44x. Positive 2 minus 2 is 0, so we have plus 0. And since 0 doesn't change the value of anything, it's often not written. That equals 90 minus 2, which is 88. So now we have 44x equals 88. 44 is multiplying the x. So we're going to do the inverse operation, just like we did here. We were adding, so we did the inverse operation of subtraction. Well, we're multiplying, so the inverse operation is division, so we're going to divide by 44, and we do it on both sides of the equal sign. So then we're going to divide by 44. So 44x divided by 44x leaves us with 1x, because 44 divided by 44 is 1. That's going to equal 88 divided by 44. That reduces down to 2. So now we have that in math, you might be thinking, well, I divide by 1. Well, you could. Yes, you definitely could. 1 divided by 1 is still just 1. This 1 is always implied. If you have an x that is written down, there is an imaginary 1 in front of it. It's an implied x, because mathematicians were tired of writing 1x, and they said, or it was understood, that if you were writing an x, you had at least one of them. So we actually reached our goal, because 1x is typically just written as x equals 2. So this is a value of 2.